more to initiate it.
Yeah, you can start, madam, because there also needs some time. So you can start.
Okay. Okay, sure, ma'am. Sure. Uh, Good evening, everyone. Uh, it gives me immense pleasure to welcome you all to the fifth day of our faculty development program on artificial intelligence and data sciences, tools, techniques, and applications. As you all know, this FTP has been designed to bring together distinguished experts and practitioners to share their insights on emerging technologies and their real world applications. So, as a part of it, today we are privileged to have with us Mr. Rajat Chakraborty, General Manager, HCL Technologies, a leader with over 27 years of experience in managing large-scale digital transformation projects across diverse domains. He has worked extensively with cutting-edge technologies such as API management, middleware, SAP hybrids, Pega, cloud migration, and data analytics. Over the years, he has successfully led global engagements with teams more than 500 professionals, ensuring operational and delivery excellences over multiple domains. In addition to his strong foundation in digital transformation, he's also deeply engaged with the latest developments in generative AI, including RAG, Agentic AI, visual language models, and LLMs. Today's session is about the fascinating and timely topic of agentic AI, an area that is currently shaping the future of intelligent systems and redefining the possibilities of human and machine collaboration. On behalf of our FDP organizing committee and all the participants, it is my privilege to extend a cordial welcome to Mr. Chakraborty. We are delighted to have him with us today and definitely looking forward to his insightful and knowledgeable session. Over to you, sir.
Thanks a lot, Sangeeta madam, for that brilliant introduction. And thank you everybody for giving me the opportunity to be a part of this session. And let me share my screen. I think I will be able to share my screen, right?
Yes, sure, sir.
Please let me know if you are able to share, see my screen visibly. Is my screen visible to all of you?
Not up till now, but yeah, it's there. It's there, sir.
It has come up, right?
Yeah, it's visible.
Okay. So let me just let you know about the way I have structured this entire thing. I will go in a very. I have not created a very enormous amount. I mean, not of. I have not created too many slides here. I wanted to keep it crisp and short, but at the same point of time, I want to touch upon the salient aspects of agentic AI framework, and also give you some examples, and also let you know as to how things are going on over here in this particular area or in this particular space, right? And if you have any queries, if you feel anything like to ask me a question, do feel free to ask me questions and all. I will be more than happy to try to clarify your doubts. Okay. So is that okay?
Sure,
From a structural standpoint, can we go ahead and start, or is there any? Yeah.
No, sir. No, please carry.
Okay, fine. Okay, so first thing first, let us go ahead and try to understand what do we mean when we say an agent. Sorry. What do you mean by when you say an agent, right? Agent, broadly speaking, an agent is an autonomous AI entity which can achieve its objectives with minimal or no human intervention using tools and services by decomposing the high-level objective into actionable tasks and subtasks. So this is a very broad definition of agent. It encompasses a lot of aspects, basically something which can work on its own given the objective that it is supposed to accomplish. So when we think of an agent, we think of an agent from that standpoint, that it has a goal to achieve and it knows how to achieve its goals. Given the tools, given the accelerators and all, it will be knowing how to get that thing done, right? That is what an agent broadly means. And if we have to do a comparison between an agent and AI assistant, because these two terms come along very close. I mean, we use them more often in an overlapping manner, basically. So just to do a comparison between these two entities, what is the difference between agent and an AI assistant? If we look at autonomous execution, agent can execute independently. AI assistant will needs inputs and intervention from user. So, for example, if you take the case of Alexa, right? Alexa will require your inputs to come out with a response. You have to give it an input, it will give you a response. But an agent does not work in that particular way. Second aspect is the execution refinement. An agent can refine its execution based on learnings, right? So agent has its own learnings based on which it can refine its execution. But AI assistant does not have that kind of a privilege. Third aspect is the tools and accelerators usage. Agent can leverage tools accelerators on its own. AI assistant has a very limited capability, or they cannot do those things in that particular sense as such. Collaboration with other agents. Agent can collaborate with other agents to achieve high level objective. AI assistant, there is no such possibility as of now. So these are the four main features which I have tried to encapsulate in this particular comparison exercise. Okay. Now, what is the need for agentic AI framework? We need an agentic AI framework in order to build state-of-the-art AI applications where we need to implement some complex workflows. We need to make sure that, okay, from a business standpoint, we are more competitive. We have to improve the customer satisfaction. We have to generate some actionable insights from a business standpoint. And these applications can be developed from a high level goal that they are supposed to accomplish. So agentic AI framework helps us to broadly create state of the art AI applications without, I mean, racking our head or our brains over how these agents should be communicating, how they should be interacting, all those things basically and all, and just looking into the high level business problem that we need to solve here. So that is the reason for using agentic AI framework. Now, scenarios for agentic AI framework implementation, I have considered 4 scenarios at a high level, but there are many such scenarios. For example, an online retailer needs to track the changes in pricing strategy of its competitors in a 24/7 mode. For example, if I am application is, say, for example, Colgate Palmolive, I'm just giving an example. I'm in the business of manufacturing toothpaste, and there are, say, 10 competitors for in my area. I'm just giving an example, who are actually competing with me in this particular space. So I need to understand how they are changing their product strategy, pricing strategy, whether there is any deep in pricing and all in a 24/7 mode. So basically, this particular thing will actually, if you can create an agentic AI solution around this particular thing, it will be able to notify me. It will be able to tell me that, okay, these are the changes in the pricing strategy which my competitors are adopting here. They have raised the prices of certain products, or they have launched some new products, whatever it is. I will be able to know that. Handle customer support queries in a better way by addressing billing issues, services not received on time, reasons for disruptions, and way forward, right? So if there is any customer support related issue, we can also handle that in a better way using this agentic AI framework, where we can create our own agents basically using the underlying customer related data and whatever service related data. We can make sure that, okay, we are able to address the customer queries in a much more efficient and effective way, right? Third is that create an application from scratch based on high level requirements being provided. So if we have the high level requirements of an application, we can also think of creating those applications using agentic AI framework. Okay. And fourth point, provide curated report on breakthroughs that have happened in the treatment of diseases. So this is another area, for example, where we see that, okay, we can create some kind of, say, for example, what is happening today in the world of cancer detection, right? what is happening, I mean, in terms of the latest breakthroughs, in terms of cancer detection and treatment and all. If we want to know all of those things, maybe we have to go back and look into, say, 10 different websites and all. Without taking the pain of doing that particular thing on our own, we can use our agentic AI framework to create agents which will be able to do that for us, right? Now, quickly moving on to the key components of agentic AI framework. So the key components of agentic AI framework, there are actually 4 different components which needs to be understood here. First thing is that it's a goal-oriented exercise, as we said. So agent needs to understand the high-level goals, and they actually ensure adherence to the goals by creating proper tasks and subtasks. The second aspect is tooling, basically tools. They are able to make use of tools, APIs, external services that are made available to them. Third aspect is the autonomous decision making, that is, they can decide on their own without waiting for any inputs from the user on what things to do and what is the next set of actions they need to take. And fourth point is the memory and context. That is, they can handle memory and context properly, which enables them to remember the background of any particular action that they are going to take. Okay, these are the 4 key components of an agentic AI framework. So any question, anything, please feel free to interrupt me. Now, I will move on to the design patterns. So design patterns
Sir,
are, yeah, go ahead.
so sorry to intervene here. Actually, have you changed the slides? I don't know whether it's from my side problem. The slide is in the the title slide.
Oh, sorry. I mean, what is going on here? I mean, I'm not, just a minute. I am
Yeah, yeah.
changing the slides. You're able to see? You're able to see any
Sugannaman,
change?
can you please kindly confirm whether the slide has been changed or it's my network issue probably?
No, I think
The slides never change.
Mm, yeah, yeah.
yeah,
Now
sir.
it is fine, sir. Now it is fine.
Otherwise, we can, sir, you can do one thing, and I think that will be much better if you just stop sharing and again you go to share screen, entire share screen mode, and then I think it will be visible.
Okay, 1 minute, 1 minute. Let me try to do that once again. Sorry for that.
No issues.
So if you select entire share screen option, from there we can get it.
Are you able to see right now?
Yes, we can see, but
Yes,
not
sir.
in the slide, sir. Just on there is an option of slide mode, so
Okay,
it
okay,
will be
slide
the
mode, yeah. But are you able to see the changes in the slide right now?
Yes,
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 yes.
yes, sir. Now we can see the changes.
Okay. So see, these are the topics which I just briefly touched upon. One is the agent definition. Okay. This is the second slide where I talked about the comparison between agent and AI assistant. Please let me know if you are able to see the slides and all. Okay.
Yes, yes, sir. Yes, now it's
Yeah.
perfectly fine.
Yeah. Now, the third thing what we touched upon is the need for agentic AI framework. And the fourth point what we touched upon is the scenarios, typical scenarios we captured here. And the fifth point what we discussed is the key components of an agentic AI framework, right? And fifth is the design patterns, where we are right now want to go ahead with the design patterns. Okay. Any questions till this point? Fine. I will. Fine. So let me tell right now what are the design. What are design patterns? Design patterns are nothing but they are basically templates which serves as a guide to understand how the agent should interact with their environment, use the tools, and also collaborate amongst themselves, right? So basic purpose is to ensure that we have scalability, we have modularity, we have adaptability built into the entire design that we are going to create, built into the way we are going to design our agents. That is the whole objective of a design pattern. Okay. Now, what are the basic design patterns in agentic AI framework? First is the reflection pattern. Okay, what's the reflection pattern does? In a reflection pattern, we have two different components, two different agents rather. One is the generate agent, or we say generate block, why I'm saying, uh, which is an agent which performs an action, right? The outcome of the action is then evaluated against some predetermined metrics by a critic block or a critic agent basically. And the critic block, the whatever the observations it has, it actually passes on that observation to the generate block once again, to the generate agent rather, right? To refine the next execution. So this way it goes on. So it's an iterative feedback loop, and one can specify the maximum number of iterations to be done. So we can specify, say, for example, after 3 iterations, you need to stop. So even before that, if it so happens that the critic agent has got no feedback to share, it may stop even before that. Or if it is continuing, it will stop after 3 iterations, like this one, like this way. What is an example? An example is that, for example, a trading agent is there, which identifies 5 top performing stocks based on their past performance. The result of this action is then passed on to the critic block, which reviews the selected stocks against metrics like ROCE, ROE, pledged holdings, etc., whatever it is, and passes the determination criteria to the generate block. The generate block then again identifies the stocks based on the feedback and passes it on to the critic block till the specified number of iterations is reached, right? This is an example of a reflection pattern. Okay. And second pattern is the tool use pattern. Agents are equipped with tools and they use them to perform special operations that need inputs from external services. For example, if you look into a travel agent uses websites like Agoda, Make My Trip, Expedia, etc., to get the best rates for hotels in a particular location on a given date, right? So they will be using all the APIs for this particular web services, for this particular websites, or the website themselves, to make sure that, okay, they are able to get all the details for the hotels and all. So this is an example of a tool use pattern. Third pattern that we will discuss here is the planning pattern. In planning pattern, what happens is that agents can come up with a plan of action. That is, they are given a high level objective to achieve. An agent itself will actually have a planner component within it, which will actually create the tasks and the subtasks. And then it will pass on those tasks and subtasks to the downstream agents, which will actually do the execution of those tasks and subtasks and make sure that the ultimate goal is fulfilled, right? Example, a loan approver agent needs to do multiple checks to understand the credit worthiness of the applicant. The planner component will plan the checks that needs to be done before approving the loan application. There will be a validator component which will use the inputs from the planner to check the details and approve the application. So here the planner will basically say what all checks and balances you need to do before you go ahead and approve an application for a loan, right? The validator component will go ahead and start checking on based on those inputs, and then based on that it will actually say that, okay, yeah, these all checks are satisfied over here, and we are okay with it, or we are not okay with it, and then it will pass on the output finally, saying that, okay, this is the output. So this is what a planning pattern design agent is supposed to do. Fourth one is the multi-agent pattern. This is a pattern basically where we are using multiple agents to achieve a single objective. So that means we can have an orchestrator over here. We will have an orchestrator over here. The orchestrator role is to make sure that all the agents are working in cohesion, basically, to achieve the common objective. For example, a coding agent generates the code from the requirement specification given to it as input. A reviewer agent then reviews generated code to check for performance issues and optimizes the code. The test analyst agent creates test cases for the generated code based on the requirement specifications. And similarly, you will have an orchestrator which will finally it can do the testing of the code or generate the test scripts and do the testing of the code, generated code against those test cases, and finally say that, okay, whether the code is ready for deployment or not, right? So this is an example of a multi-agent pattern where different agents are coordinating amongst themselves to make sure that they are able to achieve the high-level goal which they have in hand. And there is another pattern which I have not touched upon here, which is called the react pattern, which is basically reflect and act, which is basically nothing but an extension of the reflection pattern that we discussed. That is reflection pattern combined with tooling pattern makes it a React pattern. So that pattern I have not discussed here because anyway it's a combination of those two patterns. So okay. Now coming on to the open source agentic AI frameworks, I have discussed a few agentic AI frameworks over here. So first of all, I will go ahead with the Crew AI part. Crew AI is basically one of the framework. It is an old framework, and ideally it is used for any kind of rapid prototyping, basically where we need to have a quick turnaround for any kind of scenario and all. We try to use Crew AI. Crew AI actually also has a lot of documentation around it. So we can find that, okay, whether a lot of support in terms of documentation as to what kind of things it is there. It has a community, strong community support. This is basically, you can get a lot of literature, a lot of support from the community, basically, which has created Crew AI. And it has also got a low learning curve for developers. That is, you need not spend too much of time to come up to speed with Crew AI implementation and all. The cons are that the debugging issues are difficult. Maybe sometimes you will find it difficult to understand the issues which are coming up from Crew AI. And implementing complex workflows can be a challenge here also. And it's not ideal for any advanced use cases, basically where we need to create some kind of a very complex kind of an implementation and all. For that, it may become a little difficult to achieve through Crew AI. And Crew AI also works in two separate modes here. That is, one is the sequential mode, another is the hierarchical mode. In the sequential mode, what happens is that you have different agents. The output of one agent is getting passed to the other as a context, and the second agent in line that takes that particular output as an input and then creates its own output based on the roles, responsibilities, whatever it is supposed to do, right? That is the sequential model. In hierarchical model, what typically happens is that you will have a kind of a delegator kind of a responsibility. Somebody up in the hierarchy will delegate some tasks to a agent which is actually down the hierarchy, and then take that input output of that particular agent and then pass it on to somebody else. So that is the hierarchical model in which Crew AI operates. And next thing is Autogen. Autogen is a basically, although I am calling it open source, but it is backed by Microsoft basically. And this is fit for implementing any multi-agent systems and also any enterprise grade applications that we want to create. That is, for that, Autogen is also a right fit. But again, debugging can be a challenge here. The token usage can explode here, resulting in higher costs. Learning curve may be high over here because you may find that, okay, the literature, whatever is available, and the surrounding things and all, although it is there, but still your learning curve can be high over here because of some typical nuances attached with Autogen. It is also not suitable if we have to do a rapid prototyping. So basically, for any kind of rapid prototyping exercise that we need to do, we may not have, this may not be a right candidate for us. Okay. And by the way, all these frameworks that we are talking about, always remember in mind one thing, that they are always implementing all the design patterns that we just discussed. So all these frameworks, basically they are kind of implementing the design patterns that we just saw in some way or the other. They have their own variations, own way of implementing all those design patterns, right? And the third thing is Agno. Agno is one of the rising stars over here, in the sense that Agno is coming up pretty fast. It is found to be very ideal for rapid prototyping, and its debugging is also an easy task over here, because you will get a lot of meaningful messages around any kind of issues in order to debug them. It has got a strong community support, low learning curve for developers. So basically, if you are a beginner and if you are trying to do some kind of experimentation with the Agentic AI framework and all, Agno is one of the ideal choice for you. You can start going ahead and start implementing something using Agno, which will make your life, which will make things much more easier for you to start with, right? And the cons is that the implementing any complex workflow can be a challenge here. The fourth point is LangGraph. LangGraph handles complex workflows properly. It has a good observability and monitoring, and it provides enterprise level scalability, but it is not good for simple use cases. Debugging can be an issue here. It is also not ideal for prototyping. So these are the 4 different frameworks which I touched upon. I did not go to other frameworks. For example, you have got frameworks like, for example, Pydantic AI, which I did not go into over here. I also did not go into small agents. I did not get into Mastra. All these types of agents, AI frameworks are there, which I am not going to touch upon in this particular session. So that is the overall session. I mean, I had. Now, any questions? I'm open to any questions, anything around it. Sorry. Am I audible?
Yes, sir. Yes, you are audible.
Yeah. So any questions, any kind of confusion, any kind of thing where you feel like, okay, you are not able to get the essence of whatever I am trying to say, feel free to any, I mean, if you have any questions, I will be more than happy to answer that. And by the way, from a pricing standpoint, I just did not touch upon that point here. All these frameworks that we are looking at, the actual cost of using those frameworks is you don't have any cost attached with using the actual frameworks as such, but all these frameworks are using LLM as LLM is at the heart of all these frameworks, right? It's just like the engine of a car. Without the engine, the car cannot operate. Similarly, without an LLM, you cannot get these frameworks running. So these LLMs have a cost attached with them. So it is the LLM cost that we have to keep in mind. But however, if you are using LLMs, like for example, from Hugging Face and all, you will find that there are many open source LLMs over there as well, which will not require any kind of, does not come with a cost arbitrage basically. So basically we will have that kind of a flexibility also. So just to mention. Okay, fine. I think if you do not have any questions, then I think we can wrap up the session. Any or otherwise, let me know if you have any queries, or otherwise we can wrap up.
So do you have any examples how these are getting used, these frameworks are getting used in Excel Take or other industries?
Okay, so example in the sense I am giving you one real life, I mean some real life example. For example, in Crew AI, right? Crew AI, there are two things. One is that I faced a challenge sometime back, around a year back, with a particular technology which is called LTRS, which is a middleware technology which is used for the replication of data from SAP BW to our Snowflake, right? So LTRS, we were running into a lot of technical issues with LTRS processes which were replicating the data as such. So what we did is that, for example, if you go ahead and I just tried to type into an LLM, ChatGPT, for example, and said that, okay, what are the typical performance issues that you can run into when we are trying to use LTRS as a middleware? So ChatGPT gave me around 4 or 5 points and said that, okay, these are the types of issues that you can run into, right? So what I did is that, okay, fine, I created an agent basically using Crew AI. I told the agent that, okay, what we need to do is that, say, for example, when we create an agentic AI framework, we have different agents also. We tell the agent what is its role. For example, you tell the agent that, okay, you are an expert in this agentic AI frameworks and all. Sorry, in this you are an expert in LTRS. you know what LTRS is all about. You are pretty much comfortable with all the technicalities. You need to give a write 10 different points which says that okay, which are, these are the top 10 challenges in LTRS, and not exceeding 3 or 4 sentences for each of the problems, so that a layman can understand your point, right? That is the first role you assign. And you say that okay, you give that 10 problem statements in a very layman's term, but very succinctly without using too much of words, right? The next agent, what you do is that the next agent you tell that okay, against the problems being highlighted by your predecessor, that is, for example, if I call the first one a researcher and I call the next agent a analyst, I will tell the analyst that also you are an LTRS expert, but you know all the solutions to all the problems that are LTRS that you can run into when you are using LTRS, right? So, and then based on the problems being identified by the researcher, you help me to understand what are the probable solutions. Don't write too many solutions. Just give one or two important solutions around all these problem statements. Correct? And when I ran this particular agent, this researcher analyst combination together, I found that it gave me 10 beautifully crafted problems statements that okay, these are the typical high level problems, and these are the solutions around these problems, right? So my team, which was actually on the ground and trying to figure out every time that okay, how to categorize these problems that I run into with LTRS and all, they found it quite easy. They found it a ready-made material for consumption. They did not have to run around, because LTRS, the product itself, was getting supported by some other vendor in that particular ecosystem. So running around them basically means that okay, we were wasting a lot of energy, right? So when this Crew AI agent was run, we found that okay, this is the way we got that input directly from the agents. I'm just giving you one example. I know that okay, if there was some real life implementation in terms of coding and all, you could have felt better, but that is not possible right at this point of time. I could have opened it up, but this is one of the things which I can say from my real life implementation experience.
Definitely, sir. Definitely, sir. It was very knowledgeable. So anything we can do to implement this kind of things in academics, or students can do something, create some projects using these areas, frameworks, and anything. Do you suggest anything?
Yeah. So there are a lot of use cases which people can look into. For example, if you are creating, for example, the scenarios which I discussed, right? I mean, initially some scenarios I just gave some scenarios, right, over here, right? So, for example, for the coding part and all those things, right, you can start looking into agents for doing the coding work for you, right? And also look into how the code is getting generated vis-a-vis if you have created some coding on your own, you can compare that against this particular thing. Because when the reviewer in the code comes around, you can tell the reviewer to do a big O notation analysis of the algorithm that has been created by the agent, the first agent. For example, if I have a coder agent, which will actually do a coding based on specifications for the application, right? Then I can see that okay, how this code is going to fare, and I may end up doing a kind of creating an app, a miniature app kind of stuff using just my agentic AI framework. So that can be a good exercise that we can take up from a student community standpoint. Am I able to make my
Right,
thoughts
sir.
clear? Yeah.
Yeah, definitely, sir. So if anyone doesn't have any more question, we can wrap up the session. If anyone want to post anything also in the chat query, in the chat box, actually.
Okay, let me stop sharing in that case.
Mhm. I guess, sir, no more queries are there. So thank you very much for such a knowledgeable and insightful session. On behalf of our FTP organizing committee, and all the participants. We are truly, truly grateful uh, to have you among us today and for the time and effort that you have dedicated. As a token of our gratitude, we are presenting you this memento. Kindly accept it. And
Sure.
we sincerely look forward to learning from you once again in the future, sir.
Yeah,
Thank you.
thanks a
Thank
lot
you
for
very, very
giving me this
much.
opportunity, and thanks to everybody for hearing me out and giving me an audience. Thank you very much.
Thank you, sir.
Thank you.
The next session will start at 7:15 p.m.
It's in the same URL, I suppose, right? Suganya ma'am?
Yes, ma'am.
Okay.
Again, we will share the link with the audience.
We will yeah, we will. Sorry.
Thank you, participants. So we are closing the first session, and we will inform you before the second session, before 7:15 p.m. Thank you, really. Hello, Mohammed Saqib. Can you hear me?
Hey, greetings. Yes, I can.
Yeah. Greetings from our end also. Sangeeta ma'am, actually, our speaker has already joined. Sangeeta
Yes,
ma'am.
ma'am. Good
Yeah,
evening,
she has already joined.
sir. Should we start it right away? We can start.
Just at 7:15, ma'am, because we
7:50.
told
Let's
others
let's
also
start.
to join by 7:15.
Right, right, ma'am. Sir, we will be starting sharp at 7:15.
Yeah, no worries. We
Okay,
can
sir.
take time. So, Kanya, what's time is it over there?
It's 7:13 actually.
7:13. Okay.
Yeah.
What state are y'all from?
We are from West Bengal. It's
West
Kolkata
Bengal,
actually.
Kolkata. Nice. Actually, I have a guitar teacher from Kolkata. I do online classes
Really?
with him. Yeah.
Okay, okay.
He's good. I think he's famous in Calcutta. He's like one of the most prominent guitarists over there.
Oh, okay.
Oh, let me connect my headphones. It's giving me trouble.
Yeah, sure, sure. Just we'll be starting right away, I guess. छोटा बंद छोटा बंद
Am I audible now?
Yes, yes, you are audible. You are
Okay.
audible. Let me initiate the session officially, sir.
Okay, yeah.
Yeah. So good evening once again, everyone. It is my privilege to introduce our next distinguished speaker, Mr. Mohammed Shakib, Associate Cloud Infrastructure Architect for Global Financial Services. at Amazon Web Services or AWS. He's an accomplished technology expert and researcher with expertise in artificial intelligence, cloud computing, and cybersecurity. He has applied these technologies to real world challenges in healthcare, financial services, and manufacturing. In the areas of cybersecurity, he has contributed to the development of deep learning models for real-time threat detection, while also leading the creation of secure, scalable, cloud-based platforms. His work is integrating AI with cloud infrastructure, emphasizes solutions which are not only technically robust, but also ethically transparent and user-friendly. Today, Mr. Shakib will be speaking on the industrial implementation of AI frameworks, a topic of great relevance as industries are embracing currently the AI driven transformation. On behalf of the FTP organizing committee and all our participants, we are delighted to have him with us and are really eager to learn from his talk. So, over to you, please, uh,
Thank you so much,
Mr. Shakib.
Sangeeta. Those were really kind words. But I
You're
would
most welcome.
consider myself humble. You spoke a bit too much, but I'll really appreciate your words.
Thank you.
Okay, I'll share my screen. Are y'all able to see my screen?
Yes, it's visible.
All right. Hello, everyone. My name is Sakib, and I currently work for Amazon Web Services as a delivery consultant for AI-based solutions in cybersecurity. And like Sangeeta introduced me, I've been working in the industry for last 15 years, and along with that, I also contribute towards research, specifically around the area of AI ML with a touch of cybersecurity and cloud computing. And today, for today, I came up with this trending topic of implementing the AI frameworks with AI agents, and this is what's been relevant right now in the industries. And before we get started, I want to set a goal for us, what we want to learn from my presentation and my workshop. So the goal is simple. I want to start with helping y'all understand the concept of agentic AI. Now, the agentic AI, y'all probably have heard in last 5 days as well. It's a trending topic in industries as well, not only in academia. And that's what we are going to discuss today. And throughout this presentation or the workshop, I might dive a little deeper at times. And I'll be presenting some demos as well. And those demos might feel a bit technical and not immediately clear, but that's okay because even if you don't walk away remembering every detail, as long as we all live with a solid awareness of what agentic AI is and why it matters in industries, then we'll have achieved our goal. So let's set up an agenda for today. I'll go over a bit of overview on agentic AI. Then we'll discuss like how the current industrial AI landscape is looking like right now and how the agentic AI is going to reform it. And then we'll go over like very high level agentic AI fundamentals and what frameworks are being used for industrial implementation and what are the best practices for that. And I will also discuss few use cases and case studies that I have personally implemented for AWS's customers. And at the end, which is going to take most part of our presentation today, is going to be demos on AWS Cloud. Now, I'm not sure how much awareness or how much familiarity do y'all have with AWS, but AWS is a public cloud service, and it provides you with software as a service and infrastructure as a service resources which you can use to build solutions. And in the demos, we will prepare some agentic AI solutions around a sample use case for a bank. Now for the
May I
overview
ask a
of
question,
yes,
Mr. Shakib?
yes,
Yeah. So, as you said, your last point, demo on AWS. So, are you going to show how to host a agentic AI model into AWS with
y-
either Bedrock or
yes,
SageMaker? Is that what you are going to say?
yes. So I'll be showing
Okay.
like how to host agentic AI on AWS Bedrock, and then
Bedrock.
I
Okay.
do
Sure.
have this workshop document that I can share with you all as well. So if you all have AWS account for yourself, you can implement that yourself as well later on.
That's
But
great. Yeah. Very
but the
good. Thanks.
goal is very simple for us, right? We just want to see uh, how it works. So overview of agentic AI, you probably have heard in previous sessions as well that right now the trending topic in the industries is after generative AI is agentic AI. And we are at a tipping point in the industry as for decades industries have relied on automation and systems that are rule based, and then there comes the machine learning models to increase efficiency. But these systems were often rigid as they work well in the stable environments, but they struggle in dynamic, unpredictable conditions because they lacked action-based execution. So that's where the agentic AI comes in. Compared to our generative AI, which simply predicts outcomes or data based on the prior pre-trained model. Agentic AI, on the other hand, can take initiative on the predictions that are made by the generative AI, for example, and it can interact with systems or even collaborate with other agents or human as well. So we can have the human in the loop as well. But today we will be exploring how agentic AI frameworks can be implemented across industrial domains from fundamentals to framework to real world use cases, implementation strategies, and how the future outlook is going to look like for the agentic AI. So if I have to show how the agentic AI looks like is the formal definition for agentic AI would be the autonomous AI system that can observe, reason, decide, and act towards achieving some goals. You could think of it as moving from predictive AI to proactive AI, and key characteristics would be autonomy as agents can operate with minimal human intervention, and the other one would be reasoning as they can analyze trade-offs, simulate scenarios, and make informed decisions based on the predictions or determination from an underlying model or based on the environment. They are quite adaptable as they can be adjusted to perform in a specific environment with handling specific conditions. Collaboration is another one, another one of key characteristics for agents as they can collaborate with other agents, APIs, or other systems, or even human. And the agentic AI frameworks can be implemented with existing frameworks like LangChain, AutoGen, Crew AI, and AWS Bedrock Agents, which is a new AWS service recently introduced, which simplifies how you can create the agents using a software as a service model. So challenges with the existing AI landscape is most systems are siloed as they work in isolation, and they're disconnected from the broader process as they cannot take proactive actions. And they are implemented on the static model. So you would either retrain a model, fine tune it, and based on that, you would implement something to predict use cases or outcomes, but it's not going to achieve those outcomes. To achieve those outcomes, you need something else. And they respond to only when the data is pushed in. So you have to have a data set to train those models, and what kind of data you have. It needs to be labeled and not labeled. You have to determine all those, but only it can do the predictive determination. It cannot do the reactive ones. For the reactive ones, like if we have a prediction, then based on that, we might want to react to those predictions to achieve some outcomes. That's where the agentic AI comes in. And with the agentic AI, we can integrate our legacy AI systems with existing systems like ERP or MES or SCADA systems. And if we get the human in the loop model associated with this, then we are continuously training our AI landscape to not only be predictive but also reactive at the same time. So framework we use for industrial implementation whenever we are implementing some LLM model with AI agents is the common pattern is we have one central agent, and that central agent is also called a supervisor agent. And that supervisor agent is basically what's orchestrating or controlling all the underlying subagents. And then we have a concept called edge agents, and edge agents are deployed near equipment to process data in real time for critical safety and control decisions. And then we have a hybrid architecture which consolidates both of those. So if I have to give an example of this is we implemented something on a cybersecurity system. So we have intrusion detection systems implemented for one customer, and on those all the devices had one edge agent deployed on it, which was continuously looking for the patterns in the packets. And if it detected any packet with a similar pattern for the DDoS attack or MITM, it was orchestrated by the central supervisor agent to isolate that device from the network. So that's how the agentic AI architecture would look like in industrial implementation. Then integration, like I talked about in previous slide, it can be integrated with ERP and MES systems, SCADA, and even IoT systems. And like I was talking about the previous example, so we use Cisco APIs for isolating the firewalls in in an industrial setting. And what I'm trying to convey across is that the agentic AI systems can even be integrated with the external APIs. Like in this regard, we integrated that with the Cisco API to take actions based on the detected patterns. So industrial use cases for agentic AI would be predictive maintenance, where you have traditional predictive models forecasting when a machine might fail. Consider the example I was given for the intrusion detection systems. And AI, an agentic system can schedule maintenance, check for spare parts if you are in a logistics department, or even reschedule production change items to minimize downtime. In supply chain optimization, agents can negotiate across suppliers, dynamically reroute shipments, and adapt inventory to plan in real time based on disruptions. Process automation, agents can orchestrate tasks between humans, robots, and IT systems. Y'all probably might not be aware, but the agentic AI is being introduced in the service now. If you all have heard about that, it's a ticketing system. So that, for example, can process tickets or provide a ticketing system where you have determined action based on what the underlying problem is. In the quality inspection, it can be combined with computer vision to detect defects. Language agents can classify defect severity, and orchestration agents can decide whether to rework or scrape items. And it's being used in the energy optimization as well, as agents can balance production targets with energy usage, shutting down non-essential systems during peak loads while keeping core operations running as well. Now, in industries, we have a step-by-step process in identifying and implementing the agentic AI. So first, we have to identify high return on investment use cases. And that's where we start with the bottlenecks and and use cases where operational cost is too high. And then we run a controlled pilot to develop a proof of concept in one point. Then we come up with integration strategy, like how we are going to integrate that with the existing systems, if it's with the external APIs or IoT systems or internal ERPs or web applications, whatever it could be. Then we consider if we want to have the human in the loop controls for the critical systems, like if we have to take a critical system down, do we need to have human in the loop controls enabled for that? And we also consider scaling strategies, like how we are going to scale out the agents across the production environments. And finally, we implement the observability and monitoring systems around it to govern if the agents are performing exactly how we expected them to perform in a production environment. Now, the recent case studies, these were the projects I was part of recently for AWS's customers. For one of the global automotive manufacturers, we brought down 30% of the downtime that was being introduced in the change board whenever there was a change going through. And this was specifically relevant with the cybersecurity system example I was giving earlier on. And it cut down the 30% of the operational cost as well, which was estimatedly saving 40 million in annual savings, considering it how it isolates the DDoS attacks and the MITM attacks. Then for another logistics firm, we reduced delivery delays by 18% as we created chatbots for them. And those chatbots were equipped with agents that could orchestrate delivery for the customers. And another example is in the energy industry, where we increase efficiency by 22% and the emissions, the carbon emissions were cut off by 15%, and that was all because of the agentic AI as well. The increase in efficiency was because we did not need human intervention whenever we needed to rebalance the energy across the different grids. It was all done by the agents based on the uh, predictions forecasted by the prior data sets that were already trained in an LLM model. So how the future outlook is looking like for the agentic AI is we probably are going to have self-learning agents at some point. We already have introduced human in the loop strategy for that. But those with self-learning agents, we will have systems that will continuously refine their strategies, exactly like how we have underlying models which are also continuously learning as well. And then human AI teams, kind of like we have a concept of vibe coding where um, we have a generative AI helping us write codes. We'll have similar approach for the agentic AI as well, where operators will be augmented with AI agents. And right now, there is not much ethical and regulatory frameworks around the agentic AI, kind of like ISO 27001 and PCI DSS or HIPAA. That's where we are lacking, but governments or the state bodies are going to start introducing those standards around how we can implement ethical AI on a state level. So before we go on demos on AI applications on AWS with Strands SDK, do we have any questions around this? And at any point, if anything sounds confusing, please feel free to interrupt me. I'm happy to answer any questions. So I'm assuming so far y'all might have an idea on like what agentic AI is and how it's changing the industrial landscape.
Yes, 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 we do have. Yeah.
Nice. Okay, so before we start off with the demos, I wanted to introduce Amazon Bedrock. Amazon Bedrock is an AWS's fully managed service that makes it easy to build and scale generative AI applications without managing underlying infrastructure. It gives you API access to foundational models from multiple providers, including OpenAI as well. So with that flexibility, you can choose the right model for your use case, whether that's a text, chat, images, video, or embeddings. And on top of this, Bedrock provides agents for Bedrock, which is a feature of Amazon Bedrock. And that's a framework which you can use for creating agentic AI systems. And these agents can reason, plan tasks, call APIs, interact with enterprise data. And the key value you would get with the Amazon Bedrock is you can build production ready AI solutions which are already being used in the industries, while also combining those with AWS's other existing services for like security and compliance and scalability. So Bedrock is the foundation on public cloud that lets industries move from experimenting with AI to actually deploying production grade intelligent agents. So in demo one, we will create an agent for a mortgage application. So we will create a generative AI chatbot that interacts with the customer, and we will integrate that chatbot with an AI agent that will orchestrate the process of a mortgage application. And this agent will send that mortgage application in the queue uh, in the backend. Then the second demo will be around the multi-agent collaboration. We'll create two additional agents. One to answer general questions on mortgages. We will associate that with a knowledge base or knowledge base which will be integrated as a RAG or retrieval augmented generation model with the existing LLM model. We are going to use Claude Haiku for this. Then we'll create another agent which will answer questions on existing mortgage applications. And like I was talking about the architecture, the industrial architecture for the agentic AI using the central orchestrator, we'll create a supervisor agent which will orchestrate the requests between the multiple agents. And I wanted to introduce these two technologies before we dive into our demos. One is the MCP or Context Protocol. It's an open standard system that defines how AI models can connect to external tools, data sources, and systems. Um, so MCP provides a consistent interface for exposing functions, APIs, and workflows to AI agents. You do not have to do everything from scratch. This is a framework which you can use to quickly and easily implement AI agents and integrate them with the external system. So in short, it means you can plug in business systems like databases, CRMs, APIs into your existing models to create agents without rewriting the custom connectors. So in industries, MCP is simplifying interoperability by reducing the integration overhead. And the other one is the Strands SDK.
Sakib, one Sakib, one question. So this MCP, is it similar to QAI or something different?
It's something different. It's more of a protocol that you would use to connect to external systems. It's basically, if I have to find a similar thing for this, would be a RESTful API controllers, but for agentic AI.
Okay. So it gives the tool sets for creating external APIs for our agents. That's what it does, is it?
Yes, not APIs, but integration with external APIs.
Okay. Okay.
Then there is the Strand SDK. So Strand SDK is a developer toolkit for building agentic AI application. Like on AWS, although you can use console to create those agents, but with Strands SDK, you can programmatically do the same thing as it provides you pre-built components for creating, coordinating, and deploying agents. So you don't have to do it from scratch. It's a framework, comes with libraries, and you can define agents, goals, and their workflows, like multi-agent collaboration, and integrate that with MCP to connect to external systems or APIs. And if I have to summarize the SDK, the Strands SDK, it gives developers the building blocks to assemble complex and coordinated agent system quickly using simple solutions. And using these two technologies, we'll have our third demo where we will integrate our previously built multi-agent system with a credit check API. And that API will be integrated with the MCP server. So any questions so far? I would take that as a no. And before I move forward with that, let me share this lab document. Oh, I do not have option to share files over here in the Teams chat. Okay.
Oh,
I'll send this to Sukanya and she can forward to all the participants later on.
that would be great.
Okay, sure. Yes, I will forward to other person.
All right. Allow me a minute. I'm logging into the console. How many of y'all have experience working with AWS and to what extent?
I have experience working with EC2, S3, those things. I did not use Bedrock. Such.
Hmm. But you have heard about Bedrock?
Yeah, yeah. Bedrock and SageMaker, I have heard about it, I've read about it, how to use, but didn't write any ML program on Bedrock yet.
Oh, what's your background?
Actually, I was in IT for 26 years and then moved to academics. I was in Cognizant
Academia.
before that.
Oh, nice. So you are a researcher now?
Yeah, trying to do some research. Yes,
Okay. Are you like a professor or just like a
I,
student?
I'm a, no, I'm a professor.
You're a professor. Wow. Yeah, I mean, you have 26 years of experience. You are a veteran, honestly.
No, no. So, but these are all new things, right? So here
Yeah,
you actually teach more.
you have probably seen from like those bulky computers coming all the way forward with agentic AI, right? That's a long
Yeah, I have
journey.
seen a lot of changes. You're right. I've seen a lot of changes. I've seen even the Blackberries and then to iPhone now. So yeah, a lot of
Yeah,
history.
iPhone, yep. I mean, if you remember, there used to be those dial-up phones.
Yeah, yeah, that's right. That
I
was
hardly
there in
see
our
them
days.
now.
Ah, true. Is right.
We are feeling like a old person, right, Second sir?
Yeah,
I am an old person, so that's fine.
let's not talk about age, okay? He's young at heart.
Ah, wow, very good. That's good.
Right? He's see,
Right, definitely. Yeah.
he just switched to academia. He wants to do good for the society. Otherwise, he was good earning with Cognizant, right?
That's right.
Yep.
Actually, Sangeeta is like that also, right? Sangeeta was also TCS
Yes,
and
I
then
have
now
been in
into
TCS
academic.
for 20 years. Yeah.
20 years. Wow. But I have heard great things about TCS, honestly. Okay, let me share my screen. All right, so building agentic AI applications on AWS. So there are three specific services on AWS which we can use for building and deploying AI agents. One is Amazon Q, which we are now going to discuss. It's more SaaS based. It's very specific, niche specific, so it doesn't provide much customization, so we are skipping it. What we want to do is we want to build some custom agents. So for that, we are going to introduce Amazon Bedrock, and we'll create a few agents with Amazon Bedrock agents. And we'll do the same thing we do with the Bedrock agents, but using the Strands SDK. So Strands SDK is fully customizable and it can create agents in very detailed specific manner. So if you have like a very specific use case, that's when you would go for the Strands SDK. So the first AI agent we are going to build is just going to be a mortgage assistant, which is going to create a mortgage application for a customer who is interacting with a chatbot. So the function or task we will associate it with this agent is it can get the application details, it can create loan application, and it will create a customer ID. For now, we are just going to use dummy data for this, but you will see this how it works um, in action. So let's do this one. So by the way, how do you pronounce your name? Saikat or Sekat?
Yeah, Saikat.
Saikat. So Saikat,
Yeah.
I'm using SageMaker Studios for this. And in
Okay.
SageMaker Studio, I'm using Jupyter Lab, and Jupyter Lab is just a simple IDE that provides Python interpreter for you. So that's what we are
Sure.
going to use today.
Sure. Okay.
And I have this notebook, and in this notebook, I have multiple Python commands, and we are going to execute one by one on the Python interpreter. So, um, the first lab is just building a simple AI agent, which will provide assistance with the loan application. So basically, just installing the underlying libraries. And later on, I'll share all this with you. I'll forward all this material to Sukanya and she can forward to all the participants. So over here, there are two libraries I want to discuss. Is one is the Baro3, which is AWS API, and the Baro Core. Both of them are the AWS API, and we will use these APIs to create Bedrock agents programmatically. We are now going to go in console and create those from scratch. We are going to create those programmatically.
So, Sakib, is Boto 3 free or it's licensed?
No, it's free. It's a Python library.
Okay.
And I'm assuming y'all have like bit of experience with Python. Not bit, probably extensive.
Yes, I
So
guess
we are
more or
go.
less.
What's that? More or less,
I
okay.
guess
Yeah,
more or less everyone have a bit of idea about.
yeah, okay. So if you go through the code, you will have idea on how it's working, honestly. So I'm just declaring some variables over here to name the agent. And the important thing in this notebook is the agent instructions and the core behavior we define. So over here, we are doing the prompt engineering. We are tasking this agent for a specific use case where it's going to help new customers start a new mortgage application. And then we define core behavior. The one core behavior I want to discuss is for the calculations, LLM models, they do not perform well because they are based on predictions, so they cannot perform calculations. But LLM models are also equipped with code generation and interpretation capabilities. So if we have to perform any calculation, they can use that code generation capability to perform calculations. So we are setting that behavior over here. And then we will just use this API call to create an agent. Now, this agent, we will integrate this agent with this simple API we have, which can get the parameter names and the mortgage application status and the details of the application. It can create a customer ID. All these are API functions. So we'll create this API. And then we use OpenAI schema to integrate those API functions with the agent. So we are defining each of the function, what it's for, and what it can be used for. So this will assign or train the agent to perform those specific actions whenever there is a similar context being triggered in the chatbot or whatever application is integrated with that. Now we are just associating this API with the agent itself. So now if we go on the AWS console, Amazon Bedrock, agents, we'll see an agent over here. This is mortgage application agent. So I need to create an alias for this. Okay. So now if I talk to this chatbot, hi there.
So, sorry, Sakib, I missed that part. From AWS console, what did you do and how you connected with
So
your certificate ID?
using the Boto 3 APIs, right?
Hmm.
Like I mentioned, we wouldn't be creating the agents through the console. So what we did is we went to the Amazon Bedrock, right? And under agents,
Right.
you can create an agent through here, right? And then you can associate this with the APIs or the Lambda functions. So
Oh,
Lambda function is basically AWS's service where you can run serverless functions.
right.
But I created the same thing by using the Boto3 API calls. So
Understood.
this agent we created using AWS APIs. So programmatically, I'm doing this because it's easier and it's consistent. We can do it with the console as well, but it's more consistent with the code, and I already had that code ready, right? So I would rather use that to create this agent. But once you go through this step by step Jupyter notebook, you will exactly know like what it's doing. It's
Understood.
easier to understand and it's like very descriptive. So this agent is now ready
And
and
Sakib, one
yeah,
question. Sorry to disturb,
no worries.
but I have a few agents which are actually built on. I have built on Google Colab. So how easy it will be for me to port those to AWS and host there?
It depends what your use case is, but if you used Strands SDK to build those agents, it's very easy because you already have a schema, you already have integration, and you already have the orchestration defined using the Strands SDK. And Strands SDK is the open platform, right? So you can use the same thing on AWS to just execute that, and it will create all those agents for you.
Oh, okay. Actually, I used Crew AI for doing all
QAI.
the agent orchestration. Yeah.
Oh, okay. So maybe I'm not exactly sure if AWS supports Crew AI
Uh,
integration.
mm, okay.
But I can look it up. But with the
Okay.
Strands SDK, you can definitely do the same thing.
Understood. Okay. Sure. Thanks.
So I set the context of the chatbot to apply for a mortgage application, and it's prompting me for questions. Now, this application was all being interactively asked by the chatbot, which is powered by Claude Haiku model. And that Claude Haiku model is associated with this agent, which was prompting me for all the specific questions around what information is needed. And using all that information, it sent this application in the backend. So I can also perform. So it can also retrieve the status of my application. So it's saying this part is completed and what's missing. So this is, if you look at it, how this is performing specific tasks. It's impressive. It's orchestrating API calls by itself and using the information it gathers from a user. Then let's move on to the second lab. So the second lab, this is more of like how the industry is implement the agentic AI systems, as we have one orchestrator agent, and that orchestrator agent is what orchestrate different tasks among the sub agents. So we already created this new application agent. We'll create one more general mortgage question agent, and then existing mortgage agent which can get the details of the mortgage, which was in the previous one was part of the new application agent, but we'll move it to a new agent. And there's going to be a knowledge base. So knowledge base or RAG is a similar concept, but in AWS we mostly use knowledge base for this. So RAG is retrieval augmented generation, where you integrate your LLM model with a knowledge base, which can be used to retrieve specific information around some context.
And Saki, for RAG here, do you also use any vector database? Will AWS support that?
So you can use a vector database like OpenSearch for this, but we are going to keep it simple and we are going to use the S3 bucket for this now. And Amazon Bedrock will take care of creating those vector matrices in the backend.
Oh, the embeddings and all, it will create itself, is it?
Yeah, yes. So it's a managed service, right? So we don't have to do it manually.
And S3 can store our embeddings. It has
Yes.
that capability. Oh, okay. That's great.
Not the S3. S3 will hold the knowledge base, but Bedrock itself will create those embeddings. using the data from S3 bucket. You can
Oh.
select your source as OpenSearch
Hmm.
if you would like, but what we are going to do is we will now dive that deeper. We'll let Amazon Bedrock manage it for us.
Okay. Sure.
So the first one is just creating a knowledge base. Again, we'll use the Boto3 APIs to interact with AWS systems. So see, here is what you were talking about, the vector base vector store. It can be any of this option, but we are just going to use S3 bucket and let Amazon Bedrock manage the vector embeddings for us.
Where is it creating the embedding?
It's the managed one, so we wouldn't have access to it unless we
Oh,
create our own OpenSearch server.
okay. Okay. Understood.
So for the RAG, we are just using these two files. These are two HTML files I got from Investopedia, and it just have information around mortgage. So the knowledge base is created, and we can test this RAG if it's getting that specific information from the knowledge base we uploaded. Okay, so this is specific information is coming from the data set we uploaded for the RAG. And I'll just store this. And in the next notebook, we are going to create two collaborator agents, one for handling the general questions about the mortgages, and this agent will be integrated with the knowledge base we just created, and then another one to handle questions around the existing mortgage applications that are already in the queue, being processed or are already processed. Again, it's the same process we did for the demo one. We set the context and the core behaviors. And then we are going to create the second agent. Same thing. We set the context. We use Boto3 API to create the agent on AWS under Amazon Bedrock agents. And we create an API for that that will be associated with the existing mortgage assistant agent, and that can get the details on the mortgage and how it's going to populate the response for us. So just dummy functions over here. And then we have OpenAI schema to define the integration with the LLM model for this specific agent. And here we are just associating the agent with the API function we created. And then I'm just going to create an alias for this. So finally, we are going to create the orchestrator agent or the supervisor agent, which is going to orchestrate tasks between the three agents we created. The three agents being one is the new application agent, general mortgage agent, and existing mortgage agent. And this agent will supervise all this. Now, I'm not going into very deep details around how code is working, but it's very simple. If you will look it up, so we'll create an agent using Porto3, and then we are going to associate all those sub-agents with the supervisor agent. And then we define the schema for this using OpenAI schemas. Okay. All right, so if we come back to the agents console, we'll see multiple agents over here. Now, this mortgage assistant is the supervisor agent that we just created. And if we have to test this out, let me zoom it in. Now over here, you would see that this is this supervisor deferred this task to the general mortgage agent. And if you look at over here, it's talking to the mortgage application agent for this. So these two these two different tasks were offloaded to the sub-agents, and that's how the orchestrator model works. It can consolidate your multiple agents into a single one where it can, based on context, defer tasks to the sub-agents. Now in the third lab or third demo, we are going to do the same thing, but we'll introduce MCP systems over here. So MCP is going to talk to an external service, which is the credit check API, and it's this API is going to provide us the credit score for a given customer ID. And we will build all this using Strands SDK. So we won't see all these agents over here in the console because those are being initialized and being executed by Strands API. So MCP server. So here is the API that I'm talking about. It's a very simple dummy API, and consider this as an external API. Then we have an MCP client which connects to the external, in this case, credit check API. And then we will integrate this with the agents, kind of like this way, where your supervisor agent will talk to MCP client to get information from an external source, which in this case is the credit check tool. So let's start that. Okay, so this API is listening on port 8080. Consider this as like external API. And then we have a client running, which we will integrate with the supervisor agent. Okay. So over here, one thing I will want you to notice is that we are importing this strands libraries in the Python interpreter. So later on, you would see how we are using strands libraries to create those agents instead of using the bot 3. We will create a knowledge base. Then we'll set this agent for the general mortgage questions. Another agent for the existing mortgage questions. And our final agent for the new applications. Now, if you look over here, it's here we integrate our supervisor agent with the MCP server that we will initialize over here. So the MCP server is hosting the credit check API, and then we have MCP client running on our local port 8080, and this MCP client will connect to the external API. And this supervisor agent will orchestrate tasks between all those agents and MCP client.
So this MCP server will, in this case, it's talking with the credit check uh, API. So it will get back some credit score or some value, right?
That's right. So
Is,
consider
is,
this
is there,
MC. Yeah,
is there a standard format, like is it JSON or some standard format through which it comes back? How?
it's JSON. Like it's
Oh,
a you can consider this as an extension of RESTful API. But that JSON itself is processed by the LLM, so you don't have to perform any
oh,
transformation.
I'll just pass it to LLM and it will take care of it. Oh,
Yeah,
okay.
so basically you don't have to do any of the transformation with that. You just have to make sure you have the API functions defined in a way where it can get that information, and that information will be transformed by the LLM itself and integrated in the responses.
Understood. Okay.
So now over here, if you look at it, we ask this supervisor agent two questions. One, what is my credit score? My customer ID is 1111. And you can see over here, it's retrieving our credit score, which is 70. And if I go over here on the MCP server, you can also see the request coming in. And it's 200. The request was accepted and it responded. It was a post request, RESTful API, and it responded back with the credit score for the customer ID that was given. So if you look over here, see how simple it is to create a response for this. And it's using streamable
This is
HTTP.
uh, uh, okay. This is how it is giving back. Okay.
Yeah. And this is the client I'm talking about. So if you look at the how it's processing, it's getting the user input, and this is being forwarded by the agent itself. And whatever the response come from the client, it's integrated within the LLM response itself. And then it we asked another question, like why do so many people choose a 30-year mortgage? So this was, if you look at over here, it's using the general mortgage questions agent to answer this question. I specifically configured the context to for the LLM to let us know what underlying tool it is using, so we can have more verbose uh, information over here. But you can see it's using tool one, answer general mortgage questions, and over here it's using the credit check tool, tool number one, credit check. And that's all. So what I will do is I will share these files and programs with y'all. I did have this PDF prepared, but I don't think I do have a way to share this on Teams. So I'll send this to Sukanya and you can try to do it yourself at home whenever you get a chance. Or even if you do not do, I hope y'all learned something new about the agentic AI, specifically around like how it's being implemented in the industries. And also maybe have some familiarity on how we can do the same thing on AWS to achieve specific goals. And I hope y'all had an idea on like how we can implement the supervisor agent or the central orchestrator to defer or offload different tasks based on the context to the subagents. Um, and how do we configure the knowledge base that can be associated with one agent. And I also hope that we have an idea on what MCP is and what the Strands SDK is. So that was basically my goal for today's presentation.
Very
This
nice
was a
presentation,
very,
Shakib.
very, yes, yes, excellent presentation. I think,
Especially the labs are very, very nice. Thank you very much, Shakib.
Yep,
exactly, Shakil. I think I'm echoing everyone's feeling here when I'm saying that we are all walking away from today's session with a lot more clarity about agentic AI and how to implement it in AWS and any other way also. Thank you so very much for generously sharing all your insights and experiences with us, and for definitely for this demo. And
absolutely. I'm happy to be here, and I really appreciate Sukanya specifically for this. She has been collaborating with me for a while, and she scheduled all this. So thank you so much, Sukanya, for inviting me for this. I really appreciate you for providing me with this opportunity. And I had a chance to collaborate with all those smart, intelligent people from all the way from a different continent. So this was definitely a long-lasting experience for me as well. So I really enjoyed talking to you all as well. And I'm happy that I was able to share my industrial experiences with you, and you were able to gain some insights from this as well.
And we are definitely waiting for such more sessions, more interactions with you to learn more
Absolutely.
and more from you.
So that's my email over here. That's my professional email, but let me also post my personal email and my contact number in the chat. So if anyone has any questions, or if anyone wants to collaborate on anything, I'm happy to help and would love to interact with y'all on any platform regarding this. So this is my
Mm.
contact number.
Sure, Shakib. We are just yes, got your info. Thanks a lot. And from our FTP organizer side, I'm presenting this memento to you. Kindly accept it. And thanks a lot for this session.
Absolutely. Thank you so much for this. This is immense for me. I am pleasured with this.
Thank you. Thank you, and have a very nice weekend to all of you, all of the participants, and to you too, Shakib. And we will be looking forward to some more sessions with you and with the participants. We'll be connecting tomorrow for the sixth and the final day of our faculty development program. So good night. Have a nice weekend. Thank you.
Thank you, everyone. Have a nice weekend. Bye bye.
Bye, everyone.